For this video, we're going to be discussing polygon angle sums. So it'd probably be good to start by defining what exactly a polygon is. And a polygon is any shape that is made of 3 or more sides. All right, so if we want to have a shape that's made of just one side, well, that's not a polygon. You can think of a circle as a shape made of one side. Well, it's a curved side, so I don't know if we'd even really count it as a side. Two sides, if we made two straight sides, well, there's nothing closing them in, so it's not a closed shape. So we got to have 3 sides to have a polygon, and it's any shape with 3 or more sides. And most of them have these nice names like, triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. These are all just, gon meaning shape, and then, gon meaning sides, and this part out here telling us how many sides there are. Okay, eventually when we get into like a shape that has 36 sides, we just call it a 36 gon, instead of trying to come up with a nice like Greek or Roman based name for it. We just put a number in front of it, dash gon, and that's how we can name it. So for this video, we want to talk about how the sides of polygons relates to the angles. And it works like this. The number of sides of a polygon is related to the measure of both the interior and the exterior by a couple formulas. All right, and let's just talk about an interior angle is the angle on the inside of the shape. And the way you form an exterior angle is that if you took the side here and you kept it going on forever, the exterior angle is the other part of it, and together they form a linear pair. Okay? So, every shape is going to have n angles on the inside, corresponding to the n being the number of sides. And it's also going to have n exterior angles. That's important to know. So let's first talk about interior angles. The interior angle sum, so that is the sum of all of the angles inside of a polygon, is equal to 180 times n minus 2, where n is the number of sides. So if we think about this, if we have a triangle, well, we've already shown that the sum of the angles of a triangle is 360. If I think about this, well, 180 times, well, I've got n, which is 3, minus 2. We know this is going to end up to be 180, but let's work this out. 180 times 3 minus 2 is 1. 180 times 1 is just 180. So we showed that this formula works for a triangle. That's 180 degrees. Now, most of you probably already know that a square has an angle sum of 360 degrees. Okay, and if I work that out, well, 180 times the number of sides, 4 minus 2, that's 180 times 2, that's 360. Let's talk about how this works. How do we come up with this? Well, the way that it works is if I take my rectangle, square here, I want to split it up into triangles because I know the number of the sum of the angles of a triangle is 180. And they need to be triangles that don't overlap. The way I do that is by connecting the vertices of my rectangle with what we call a diagonal. If I go like that, I can see, well, if I connect my vertices there, I can only draw the one line, because if I draw another one, well, then I've got overlapping triangles, and I don't want to have overlapping triangles. So I can split any rectangle into 2 non-overlapping triangles. And if I know that each triangle has an angle of 180 degrees, I just do that 180 times my number of triangles, which is 2, and that gives me my total sum, which is 360. So that's how this is derived for every single polygon, is you split it into triangles, and there will always be n minus 2 triangles that the shape can be split into. And then from there, now you can say, well, I've got n minus 2 triangles. I take 180 times n minus 2, and I have my angle sum. Let's look about this for a pentagon, all right? Five-sided shape. Well, if I want to split this into triangles, one way I could do that, I can draw a line here, okay? So now I've got one triangle and I have this trapezoid, and then I can draw another one like this. Now I've got three triangles. 1, 2, 3, right? Which is 5 minus 2. Now I could do it a different way. I could draw two lines from this vertex, one down to here, one down to here. You'll notice I still have 1, 2, 3 non-overlapping triangles. Okay, and there are several different ways that you can do this for a pentagon, but either way you're going to end up with three triangles. So if I plug that in, I get 180. That's a terrible zero. 180 times 5 minus 2, which is 3. So 180 times 3, which gives me 540 degrees. So it's pretty simple to find the sum of the angles of any polygon. You simply take the number of sides, subtract 2, and multiply it by 180. Now this does not tell us what the measure of each angle is. It just tells us what the sum of the measures of the angles are. And that's all there is to it. So let's look at some examples. Example 1 says, find the sum of the interior angles of a heptagon. I know a heptagon, that's 7 sides. So pretty easy. All I need to do, plug this 7 from my heptagon into my formula, 180 times n minus 2, n being 7. That's 180 times 5, 900 degrees. Pretty simple. Now we can also go the other way. If we know the measure of the angle, or the sum of the measure of the angles, then I can figure out how many sides the polygon has. So the way I do that, use my formula, plug this in. 6,840 equals 180 times n minus 2. Divide both sides by 180, and I get 38 is n minus 2. Add 2 to both sides, and I have a shape with 40 sides. That's all there is to it for interior angle sums. Now, exterior angle sums is even simpler. For any polygon, the sum of the exterior angles is 360. Every time, no matter how many shapes, or no matter how many sides. Now, I'm not going to do any examples with these, but I am going to quickly prove to you that this is true. And what we need to know for that to be true is that we know our interior angle and our exterior angle form a linear pair. Okay, so they equal 180 degrees. Okay, that's something you need to make sure you know for this to work. Now, if I take each one of these linear pairs, well, if I've got n pairs, right? I've got one pair for each side. So I've got this pair, I've got a pair here, a pair here, a pair here, and a pair here. Okay, the sum of all of those linear pairs is just 180 times n. I've got n linear pairs, they all add up to 180. Therefore, add them all up, I get 180 times n. So if I want to find the sum of the exterior angles, just the exteriors, well, that's going to be the sum of the linear pairs minus the sum of all the interior angles. Well, I know the formula, or I know that the sum of the linear pairs is 180 times n, and I know the sum of the interior from my formula is 180 times n minus 2. So the sum of the exterior is 180n minus 180 times n minus 2. So now we just work this out. First I distribute. Negative 180 times n is negative 180n, and negative 180 times negative 2 is positive 360. Well, here you see I have 180n minus 180n. Those cancel each other out, and I'm left with 360. So no matter how many sides a polygon has, the sum of its interior angles is always going to be 360. So to quickly sum it up, the sum of interior angles of a polygon is always going to be 180 times n minus 2, where n is the number of sides. And sum of the exterior angles is always going to be 360 degrees, no matter how many sides the polygon has. So there we go.